Hello all. In this video, we will study how bitwise right shift operator works. So let us see an example. Suppose we are given a variable x and it is an unsigned integer. So we can only store non-negative values into it. And imagine suppose we have stored 120. Okay. We also assume that integer requires 2 bytes. Right. So 2 bytes means 16 bits. Now the binary equivalent of 120 is shown over here, right? These are the 16 bits we have, and this is the binary representation of 120. Okay, perfect. So now imagine, suppose we are using a bitwise right shift operator on x. Okay, so you can see over here on the value of x, which is 120, we are performing bitwise right shift with position 1. So each bit of x will be right shifted by one position. So each bit will be shifted to right by one position. Okay, so what happens is this 0 will come over here, this 0 will come over here, this one 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 will come over here, this 0 goes over here, and so on and on and on. This 0 will come over here, this will create a blank space over here, okay, which will be filled by 0. So this value will be 0. So this 0 is preceded, right? This 0 is, the blank would be filled by 0. So once you do that, when you shift each bit to right by one position, what happens is you get a new number, right? You get a new binary number, and this is the new binary number which you get. Okay, now if you convert this binary number to decimal, then you will see that it is 60. The original number was 120. Now what we have got is 60 when you right shift by position 1. Similarly, when you take x, okay, and when you right shift by two positions, what is going to happen is each bit of x will be right shifted by two positions. So what will happen is this 0 will all the way come over here, this one will come over here, this one will go over here, this one will come over here, this one comes there, this 0 goes here, and so on. Eventually this 0 will come over here, this 0 will come over here, and this 0 will come over here. So we will have two blank spaces now, right? These two blank spaces will be filled in by 0. Each bit is shifted to right by two positions, and blanks will be filled by 0, right? So when you do that, you get a new binary number now. Right? And if you convert that binary number into decimal, this binary number into decimal, you will find you have 30. Right? This is the decimal equivalent of the generated binary number, that is 30. Okay. Likewise, when you take x and you right shift by three positions, then this one will come over here, this one will come over here, this one will come here, this one will come here, this 0 goes here, and so on, so forth. This 0 will come over here, right? So here we will have blank positions, 3 blank positions. All those blank positions will be filled by 0. Okay, so each bit of x is shifted to right by 3 positions. So what happens is you get a new binary number now, right? This is the new binary number which you get, and if you convert it to decimal, it is 50. So you realize that right shift by 1 is equivalent to divide by 2, right? So what was our x? X is 120 divided by 2, 60. Right shift by 2 positions is equivalent to x divided by 2 raised to 2. This is 2 raised to 1. This is 2 raised to 2, which is x divided by 4. Integer division, right? Which is 120 divided by 4, which is 30. And x right shift by 3 positions is equivalent to x divided by 2 raised to 3, which is x divided by 8. And our x is 120. 120 divided by 8, which is 50. Okay. So in general, any value x right shift by n position is equivalent to x divided by nth power of 2. The only thing is here we have an integer division, right? Integer division. Okay. So I hope you have understood this aspect of bitwise right shift operator, right? Thank you.